Hello, my name is Onwara Mahawong. My advisor is Prof.Dr. Somkiat Ngamprasertsith. Today, I will present the topic of enzyme-assisted subcritical water extraction and characterization of soy protein from heat-denatured milk. I have four main contents to present: introduction, objective, methodology, results and discussion, and conclusion. Begin with introduction. From the name of topic it says, this topic studies soy proteins, so I will talk about soy proteins first. The applications of soy proteins as functional foodstuffs have been extensively concerned due to their high nutrient value and excellent functional properties. Moreover, simultaneous ingestion of soy proteins with isoflavones, another important component in soy products, has been attempted to evaluate their synergistic effects. Additionally, isoflavone glycones are also expected to be incorporated into soy protein, which may be a promising approach for further promoting health. To improve the bioavailability of isoflavones, the addition of exogenous beta-glucosidase to soy products and microbial fermentation have been executed to hydrolyze sugar moieties since isoflavone beta-glucosidase do not cross human intestine. There are several ways to improve functional properties of soy protein. First, heat treatment includes hydrothermal cooking and steam fat exposure. It successfully improves emulsifying ability of globular proteins due to partial protein unfolding. Second is protein glycosylation. The addition of carbohydrate moiety to a protein molecule. And protein glycosylation helps in proper folding of proteins, stability, and in cell-to-cell adhesion commonly needed by cells of the immune system. The last one is enzymatic hydrolysis, a process in which enzymes enhance bond cleavage in molecules with the addition of the elements of water. Soy protein isolate, or it called SPI, is usually prepared from low-denatured soy milk, obtained by extracting oil with hexane and drawback desulfitizing. In view of better solubilization of denatured protein and isoflavone, this work attempted to employ subcritical water treatment as an effective approach to preparing isoflavone-rich SPI from heat-denatured soy milk. Objective: to study characterization of soy protein by enzyme-assisted subcritical water extraction. Methodology: first, enzyme-assisted subcritical water extraction of soy protein. Heat-denatured soy milk and protease M were added to the dispersion in distilled water. The dispersion was adjusted pH to 4.5 and then incubated with shaking at 150 rpm at 50 degrees Celsius for 10, 30, 60, 90, and 120 minutes. Next, the dispersion was adjusted pH again to 9. The last step is deactivated by heating at 100 degrees Celsius for 5 minutes. The protein yield and purity of samples were determined by K-down method. These are all about to study protein composition. Amino acid composition was determined by monitoring the absorption at 254 nanometers using HPLC system equipped with a picotag column. Isoflavone content was calculated with a standard curve plotted from a series of isoflavone concentrations. Reducing sugar contents of protein samples were determined by 3,5-dinitrosalicylic acid calorimeter method using glucose as the standard. Maillard browning content was also monitored by measuring the absorption at 420 nanometers using a UV2300 spectrophotometer. The last method is protein solubility. Protein solubility was measured by Lively's method using BSA as the standard. Results and discussion. The SPI yield, or CK, obtained by conventional alkali extraction and acid precipitation at 25 degrees Celsius from heat-denatured soy meal was only 16.4%, although protein purity displayed a high level. As expected, subcritical water treatment significantly increased protein yield to 59.3%, while no significant changes in protein purity were observed. The significant decrease in protein yield and purity were observed with prolonged hydrolysis time, which may be related to the difficulty in the precipitation of some small molecular weight peptide at isoelectric point. To further confirm covalent coupling, the reducing sugar and browning of protein were thus determined as shown in Figure 2. NSPI and HSPI exhibited slightly higher reducing sugar and browning. The gradual increases of reducing sugar and browning were found with increasing hydrolysis time, probably implying the formation of protein carbohydrate conjugate. The acidic amino acids were obviously different for various SPI. In contrast to NSPI, enzyme-assisted subcritical water prepared SPI had higher uncharged and hydrophobic amino acids but showed lower acidic amino acids. This result may closely related to the fact that some peptides with charged groups cannot be recovered during precipitation processes according to the result of protein yield. Gradual increases of hydrophobic amino acids were observed with prolonged hydrolysis time, suggesting more hydrophobic characteristics of protein. It is noteworthy that with increasing hydrolysis time, basis amino acids of SPI gradually decrease, especially lysine and arginine. In view of the possibility of isoflavone conversion due to contaminated beta-glucosidase in protease M, isoflavone composition of SPI was determined and summarized in Table 2. SPI extracted from long-term hydrolysis soy meal, or M120, contain higher total isoflavones compared with NSPI, indicating the enrichment of isoflavones. This result may be related with subcritical water-induced solubilization of isoflavone and their coexistence with unfolded SPI. A gradual decrease in isoflavone glycosides accompanied by an increase in aglycones were observed with increasing hydrolysis time. So, we will see that the total of aglycone of M120 is 15.15 micromole per gram, accounted for 91.43% of total isoflavones. To sum up, contaminated beta-glucosidase in protease M may be responsible for this remarkable conversion of isoflavones by hydrolyzing glycoside into a glycone. Figure 4 shows protein solubility profile of various SPI samples. Similar solubility pH profiles were observed for all samples, with the appearance of isoelectric point at pH 4 to 5 All proteins exhibited high protein solubility at pH values below 3 and above 6. In the case of enzyme-assisted subcritical water prepared SPI, the minimum of protein solubility at pH 4 to 5 slightly increased with increasing hydrolysis time. M120 exhibited an obvious increase of protein solubility at pH 5, which may be due to long-term protease M hydrolysis. Conclusion. In this study, enzyme-assisted subcritical water treatment successfully improved protein extraction from heat-denatured soy meals, although protein purity decreased with prolonged hydrolysis time. During extraction process, the occurrence of Maillard reaction of soy protein with enzymatic release reducing sugar was confirmed. Enzyme-assisted subcritical water prepared SPI contain higher uncharged and hydrophobic amino acids, indicative of more hydrophobic characteristics. The release and conversion of isoflavones were found due to contaminated beta-glucosidase in protease M, leading to the enrichment of isoflavone glycones in SPI. Soy proteins with excellent nutritional value and emulsifying properties have high potential to be incorporated into food formulations as functional ingredients. Thank you for your kind attention. If you have any questions, please feel free to ask me.